So the types of events here, the first one is exhaustive event. The exhaustive event will be including all possible outcomes of an experiment. Okay. So when experiment is conducted, what are the possible outcomes here or all will be included in that event, then that is called exhaustive event. Okay. So when we conduct the experiment of tossing a coin, so when we toss a coin, what are the possible outcomes? We may be getting head or tail. Okay, so what is exhaustive event here? This will include both head and tail. Okay, and similarly when you conduct a throwing a die, when you throw a die, the what are the possible outcomes? When we throw a die, we will be getting the value 1 2 3 4 5 6. Yes or no? Okay, so if the event consists of all these values 1 2 3 4 5 6, then this that particular event is called exhaustive event. Okay, then we'll see what is mutually exclusive event. Mutually exclusive events, say here we have two events A and B, and these events are said to be mutually exclusive if they cannot occur together. Okay, so for example here when we are throwing a die, so we have defined event A like this. Event A is having checking for the cases where we get even number when throw a die. Okay, so event A is having values 2, 4, 6, whereas event B is having the values 1. Okay, so it will be here we are checking for odd number. Okay, when you throw a die, we are checking for odd number. So what are the values here? 1, 3, 5. So if you check event A and event B, these two events cannot occur together. Okay, so event A is even number, checking for even numbers, event B is checking for odd numbers. Okay, so that is why these two events cannot occur together. So these two events are called mutually exclusive events. Okay, so if two events are mutually exclusive, what is probability of A union B? What is probability of A union B will be equal to probability of A plus probability of B, because these two are, when you find out what is A union B, we will be having 1 2 3 4 5 6. Okay, so what is that? It is probability of A. So what is probability of A here? It is 3 by 6, because our sample space will have 6 outcomes, and probability of B will also have 3 by 6. Yes or no? So because our sample space is having 6 outcomes. Now if you find out what is probability of A union B, it is equal to 3 by 6 plus 3 by 6. Okay, so what is this value? This value is equal to, in this case, will be getting this value is equal to 1. Okay, it is depending on A and B. So here A and B we have selected such that we are getting A union B is equal to 1. So it is equal to what? Probability of A plus probability of B. Okay. Then we have equally likely events. So if you have two events A and B, so we say that the probability of occurring one event will be equal to probability of occurring the other event. Then we say that these two events are equally likely event. Okay, so if one of the events cannot be expected to happen in preference to the another, then such events are said to be equally likely events. That is, each outcome of a random experiment has equal chance of occurring. So what is equally likely event? Each outcome of random experiment has equal chance of occurring. Then that events are called equally likely event. Okay. So in a tossing a coin, what is the probability of getting head will be equal to probability of getting tail, yes or no? So this particular event is called equally likely event. Each outcome will have equal chance of occurring, then that event is called equally likely event. Okay, when you throw a die, so what are the outcomes here? We get 1 2 3 4 5 6. Yes or no? What is the probability of each outcome? The probability of each outcome will be equal to 1 by 6. Yes or no? So each outcome is having the same probability. So these events are called, so this particular event is called equally likely event. Okay, Now we'll discuss what is independent event. The two events are said to be independent if happening or failure of one does not affect the happening or failure of other. Okay, so those events are independent. So occurring of one event does not depend on other event. Okay, so that events are called independent event. Okay, so, if two events are A and B are independent, then their joint probability is given by, what is the joint probability here? Probability of A and B. See here, and in this particular case, and is nothing but intersection. Okay, or is nothing but union. Okay, wherever we use and means that intersection, or is nothing but union. Okay, now if two events are independent, their joint probability, that is probability of A intersection B, is given as probability of A into probability of B. Okay, so what is non-mutually exclusive events? The non-mutually exclusive events is nothing but, so that is the occurrence of one event depend on the other event. Okay, then these are called, because these two events are occurring together. Okay, when events are does not occur together, then we say that the events are mutually exclusive. If the events are occurring together, then we say that these events are non mutually exclusive events. Okay, so in the case of non mutually exclusive events, what is probability of A union B? So R is nothing but union, no? Probability of A union B is equal to what? Probability of A plus probability of B minus probability of A intersection B. Okay, so this is the case we use when two events are independent. Independent means occurrence of one event does not depend on the other event. Okay, in that case, probability of A intersection B is given as probability of A into probability of B. When the events are occurring together, then those events are called non-mutually exclusive events. So in that case, probability of A union B is given as probability of A plus probability of B minus probability of A intersection B. So now we'll see what is the mathematical model of the experiment. Okay. So whenever we have to write mathematical model for the experiment, we have to follow the three steps. Okay. So what are the steps we have to follow? When first step is we have to write the sample space. Okay. First we have to write the sample space for the experiment. Then what is that? We have to define the event of the interest. What is the event of the interest? We have to define. Then we have to assign the probability. Probability will be assigned to the events such that the axioms are satisfied. Okay, whenever we are assigning probability to the events, what is that we have to check? We have to check the probability should satisfy the axioms. Okay, so we have discussed that there are three axioms. What is first axiom? The probability of any outcome will be non-negative number. The second one is the probability of sample space will be equal to 1. The third one is when two events are mutually exclusive. Okay, that is probability of, if A and B are mutually exclusive, in that case, what is probability of A and B? Here we have discussed. Okay, if two events are mutually exclusive, then probability of A union B can be written as probability of A plus probability of B. So these are the three axioms. Okay, so whenever we are assigning probability to any event, we have to see that the probability whatever we are assigning should satisfy the axioms. Okay, these are the three axioms we have discussed. Okay, so now we'll see this example. So what is that here we do? Here we are conducting an experiment. In that experiment, we are throwing two dice and observing the sum of the numbers. Okay. And we should obtain mathematical model for this experiment. So whenever we are obtaining mathematical model for the experiment, what is our first step? We have to assign the sample space. Then what is the next step? We have to define the events of interest. And the next step is we have to assign the probability to the events. Okay, these are the three steps we have to follow. So what is our first step? We have to obtain the sample space. Okay, so here we are throwing two dice, yes or no? So what is sample space here? The sample space consists of 36 points. Okay, so this is the sample space. We are throwing two dice. So what is the sample space here? It will be having the value 1 1 1 2 1 3 so on to 6 6. So how many elements will be having? 36 elements. Okay, so that is our first step. So we have obtained the sample space. Now what is our question here? We have to observe the sum of the numbers showing up. Okay, so when you throw the dice, what is the sum you are getting? The least sum. 1 plus 1 is the 2 value, we are getting the least value. Okay, what is the maximum value we are getting? 6 plus 6, that is 12. Okay, so the sum will be varying from what? 2 to 12. See here, the sum will be varying from 2 to 12. Okay, now what is the next step when we are assigning the model? When we are writing mathematical model, we have to obtain the event of the interest. What is the events here? We have defined A such that the sum is equal to 7. We have defined B such that the sum will be varying from 8 less than sum less than or equal to 11. See here, it is less than here, so 8 will not be included. This B will be including the sum is equal to 9 to 11. Okay, and what is C here? 10 less than sum. Okay, so the sum value is greater than 10 will be in C. These are the three events we have assigned. Okay, so what is the first event? The sum is equal to 7. The second event is nothing but the sum value will be varying from 9 to 11, whereas C is the sum is greater than 10. Okay, so from 10, after 10, that is 11 12, what is the maximum value? Sum you will be having 12, no? Okay, so this is the events we have assigned. Now what is next step in the mathematical model? So first step is we have to obtain the sample space. We have obtained the sample space. The sample space is having 36 elements, that is 1 1 2 6 6. And the second step is we have to define the events. We have defined three events. What is the third step? We have to assign the probability such that the probability will be satisfying the axioms, yes or no? Now we see what is the probability of A. See here, ma. Check in which cases you are getting sum is equal to 7. What is your A, ma? A is equal to what? Sum is equal to 7. So in this sample space, what are the cases where we get sum is equal to 7? Okay. So see here, 5 comma 1 is 6, no? So you should not consider. Only wherever you get sum is equal to 7, that only you have to consider. So these are the cases where we are getting sum is equal to 7. That is 6 comma 1, 5 comma 2, 4 comma 3, 3 comma 4, 2 comma 5, 1 comma 6. These are the cases where we get sum is equal to 7. Now what is the probability here? Probability of A is equal to, we know that each outcome is having, what is the probability here? 1 by 36. Each outcome is having probability of 1 by 36, because how many elements we have totally? We have 36 elements. So the probability of each outcome will be equal to 1 by 36. Okay. Now how many elements you have in A? Check here A. It is 1, 2, 3, 4, 5, 6. There are 6 elements in A. Yes or no? So what is the probability here? 6 into each outcome is having probability is equal to 1 by 36. So it is equal to 1 by 6. Okay. Now what is B, ma? B will be having the sum is equal to 9 to 11. Okay. Now check whichever elements is having sum is equal to 9 to 11. Okay. So 6 comma 3 is 9, no? 5 comma 4 is also 9. Okay. 4 comma 5, 3 comma 6, and 6 comma 4 is 10. 5 comma 5 is 10. 4 comma 6 is 10. 6 comma 5 is 10. 5 comma 6 is 10. So sorry, 11. Okay. So these are the elements will give the sum is equal to 9 to 11. Okay. So how many elements you have in B now? You check it. How many elements we have in B? So it is 1, 2, 3, 4, 5, 6, 7, 8, 9 elements we have. So what is probability of B? It is 9 into each element is having the probability of 1 by 36. 9 into 1 by 36, that is equal to 1 by 4. Now you check C. So the sum value should be greater than 10. Sum should be greater than 10, means sum is equal to 11 and 12. So in which cases you are getting sum is equal to 11 and 12? So these are the cases here, 1, 2, 3. Only these three cases will be getting sum is equal to 11. So what is the probability of C? C is equal to 3 into 1 by 36. Okay, so it is equal to 1 by 12. Now check here. We are finding what is B intersection C. Okay, what is B intersection C, ma? Which are elements common to both B and C? Which elements are common to both B and C? Only these two elements are common to both B and C. So what is the probability of B intersection C? It is two elements are common, no? Two elements, and each element is having probability 1 by 36. So it is equal to 1 by 18. Now we are finding what is probability of B union C. Okay, whenever you are finding union, you should not write repeated elements. We have to write the elements only once. Okay, now check how many elements you have. It is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements you have.
10.
10 into 1, 10 into 1 by 36. So it is 5 by 18. Okay, so like that, whenever we are writing mathematical model, what is our first step? First step is to write the sample space, then define the events. Okay, so what are the events here we have defined? These are the events we have defined. Define the events, then assign the probability to the events. Okay, so these are the steps we have to follow whenever we are assigning, whenever we are writing mathematical model.